Oh, didn't define the origin. All right. So the problem starts, well, at time A, because that's when the box enters the problem. The box is already moving to the right. I guess here's the wording. A box slides toward a wall to the right. It is initially on a frictionless surface, but experienced friction about a third of the distance towards the wall. The friction stops before the box touches the wall. So that's what this symbol right here is. This is the symbol for technically the coefficient of friction, and that it experienced friction starting at time B and ends just before time D. So both ways. So there's friction in this region right here. The box hits the wall, which moves back some before bouncing back towards the starting point. It is going over the friction section of the floor the second time. The box stops, which coincidentally is the origin. So it stops at time I, and the box is at the origin at that point. So here's what's happening is that box is sliding towards the wall on the frictionless surface, then it hits friction, and then it's frictionless again, it hits the wall will deflect some, and then this will bounce back across frictionless surface, hit friction, and stop. Questions about the problem? Yes, Mario.
There's no friction on D to E, just
Correct.
D to D? Okay.
Including D, but not D.
Okay.
And the problem, I didn't have this notation here. I had the line representing from B to D, but in the wording here, B time box first reaches the friction section, so B does have friction, and D, the first mode of the box, is not experiencing friction, so D is not included. Roberto, you got a question, and then Kyle?
Do you want this paper or?
No, that was for your own edification.
Alright, so at point C, what is that word after box?
Passes. Time box passes the eventual stopping point, but while moving to the right.
Alright, thank you.
All right, so let's do this. So I guess I didn't finish that chart. This is 0, negative. And over here, I have 3 different ways of expressing the exact same answer. On a test, I'm not going to ask you to do all 3 ways. I think the last one I gave 4 different ways of expressing it and just said pick one. Occasionally there's a student who does more than one, which is fine, except for the fact that the student contradicted himself. So that's always fun to grade. Now it's possible the student started on one section and thought, oh, I really don't like this, let me do a different one. If you do something like that, just say, pick this one or ignore this one. Big X to the one you don't want me to look at. All right, so let's start out with position. And something like this, I find it usually easiest to start out with, where is it 0? Where's position 0?
I and C.
Okay. So I and C, doesn't matter the order in which you do it. Here, this is 0, and that is 0, and potentially go for just absolutely stunning visual effects. And then down here, we can shade this in. If you already know that you really hate one of these presentations, then just don't do it. Do the others. All right, so where is the position positive?
Not including C or I.
From C to I, not including C or I? So you're saying everywhere in between these two. Now, the advantage to the first method, in my opinion, is that it doesn't take up much space. It's conciseness of language. The disadvantage is some students have a difficulty knowing that they covered everything. They have a bracket here, they have a bracket there. They didn't mean to put a bracket in 2 places, but they did, and suddenly you have some point in this which is both positive and negative and 0 at the same time. I've gotten that occasionally. This one, you're less apt to leave something blank. Advantage of this one is you're practically doing the graph already. I know it's going to cross 0 here, and it's going to come over and hit 0 again. All right, and negative?
A to C, not including C.
A to what again?
A to C, not including C.
So, negative, 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 negative. Questions about position? All right, displacement. Where is it 0?
A.
All right. 0. Where is it positive?
Everywhere else, A to I. Including
beautifully shaded. Now, if you are doing this method right here, or the one, I mean, if you, this, it used to be I gave only one way of presenting the information, and you're supposed to basically use that notation. If something is blank on some case like that, if this is blank, you need to make sure it's explicit that you're intentionally leaving it blank. So either cross through it or put NA for not applicable, something like that. Just so it's clear that you didn't just skip over it. All right, velocity. Where is velocity equal to 0?
Just F.
Just what?
F.
F?
Or, figure out not friction.
Any, yeah, F and I. Did you say I?
No.
Okay. I'm sure the rest of the group appreciates you giving them a chance. All right, so this is 0 at F and I. Where is it positive?
A to B, not including B.
What happens at B?
It hits friction, so it slows down.
But we're doing velocity now.
Oh, my bad.
Oh, okay. Where's velocity positive? Wait, say it again, sorry.
A to F, not including F.
All right. So A to F, not including F, because F is over here. So oh, and this is all positive. Left that blank. And negative?
F to I, not including both.
All right. And then down here, it is 0 at this point, and then positive before, negative after. And then acceleration. Right. Where's acceleration equal to 0? Okay. Is it A and B or A to B? At A.
A to B is no friction, it's
Yeah.
constant movement.
So there's nothing slowing it down here. There's nothing to cause a change in velocity as A is moving along here. It's not until it gets the friction that it's going to suddenly start slowing down. Or will suddenly or gradually start slowing down. It'll start slowing down. So A is 0. From A to B is 0.
But not including B.
So it includes A but not B. So once it hits the friction, is it going to speed up or slow down?
It'll slow down,
So
negative.
the sign has to be opposite.
B to D.
Including D or not?
No.
All right, so it's negative from including D, but not D. And then what about happens at D?
Speeds up. There's no friction, right?
What would cause it to speed up?
Well, there's no more friction.
Right, but with that, does that mean it's going to speed up?
Yeah, there's nothing to make it speed up, so it's gonna be the same.
Yeah, so it's 0 again. And also another way of looking at it, once you recognize that it's not negative at D, there's only one choice here. It's got to be 0. You can't suddenly go from negative to positive without passing through 0.
E to F, not including F is 0.
But you said D to F?
Yeah.
But at E is the last moment before it touches the wall. So the box has changed. All right, so you have E, then it touches F, bouncing back, and as soon as it separates, you're at G. So while it is touching, so first of all, from D to E.
0.
Okay. And E, it's not touching the wall at E, because it says in the text. From E to F. That negative sign with a question mark over it?
So if you slow it down, so it would be the opposite?
It would. All right, so it is negative. Have more confidence. Even if you're wrong, just say it with great confidence. How about F to G? We'll skip F for just a moment. F to G.
Positive, because it's taking an impact. Once it hits it, doesn't it bounce back?
It does bounce back.
Wouldn't it be negative, because if you think about it, the force is forcing it back that way?
Or look at it from the point of view from F to G, it's speeding back up again. And so the sign has to be the same as velocity. So what's happening at F?
It would have to be negative then.
Yeah, it would. Primarily the force reason. The fact that it's pushing on the wall's pushing back on it. The wall is causing the thing to stop and then move, get shot back. G and E are the same location. That'll be 0. At what point does it stop being 0 again?
H, because it's hitting friction again. H, because it's about to hit friction again.
So it's still 0 there, or not 0?
It would be negative again, wouldn't it?
At H?
No, it would be 0, because that's the last
Oh,
moment is
right.
on frictionless.
Right. And so now H to its stopping point. So H,
It's slowing down, so it would be the opposite,
Yeah.
so positive.
and then I gets a little controversial here. I'm talking about that very moment that it stopped. The moment after I, it's 0. So it's still positive at this point, just incredibly tiny. So when we do our graph for acceleration, it should be getting, I guess it's coming from 0 to positive, so it's gonna do something like this, and it's gonna start coming back down. So we start out at 0, and then we go negative. And then we go to 0 again, and then negative again, then 0 again, and then positive at the very end. Now, in this presentation right here, we can immediately look and see that the regions where it is slowing down. Because all I have to do is look at velocity and acceleration. It is slowing down there. It is slowing down there. It is slowing down there. Those are the regions where it's slowing down. Because velocity and acceleration are opposite signs. The point where velocity is 0, but the acceleration is not, this would be a turning point. And there's something that exists on both sides. Probably better to see it as a turning point because velocity goes from positive to negative. I'll just leave it at term. All right. Awesome.
I don't quite understand why between H and I, not including H, that the acceleration would be positive.
All right, so 2 ways of looking at this. Friction opposes whatever you're doing. It hates whatever you're doing. So the box is moving in this direction and friction's opposing that. The sign is purely about direction, so the friction is pushing on it in that direction or pulling on it in that direction. And so,
So it's pulling in a positive direction?
yes.
Okay, all right, fair enough.
Other questions right now? Before we do the graph.
We're gonna do the graph on the test.
Yes. Oh, one other thing, thanks for reminding me about that. On this type problem on the test, where I give you a scenario and you're gonna have to do the plus negative 0 for the big 4 there, I will tell you, no two of these will be identical the entire way across. So if, for example, you find yourself in a situation where you're going, position, displacement, I can't remember which is which, so why don't I just put down the same answer for both of them? What's gonna happen is I just sort of got fed up with that, and you haven't done it. There's no reason, I don't wanna take it out on you, but just letting you know, if you put down identical answers for these two, that says, I really don't know which one of them. I'm taking a guess at one, and I really have no clue about the other one. Whichever one gets you more points, I will give you some credit for that one, and the other one I'll give you absolutely no credit for. So, just letting you know they were all different. And also, the other place where some people will do displacement velocity identical all the way across, or velocity acceleration all the way across. And I will tell you the answer. You've missed something in that case. All right. So let's do the graph. Let's see, get rid of this part. Now when doing the graph, I have my guide right here. I've already gone through this. I know positive, negative, 0. Basically, it's gonna kind of look like what I have down here, except throw some curves into it. It is more sophisticated than just that and throw a curve into it. But this is sort of a template at the moment. I've got a bunch of marks there, so I have A, B, C, D. So I have them marked off. Now, in reality, they should not be spaced equally, but this is just a sketch. So I'm okay with that. For some tests, I actually put down the letters on here, just so that to avoid those who missed the part where I say, make sure you put the letters on the graph. And other times I don't put them on there, so you can sort of space it the way you want to. All right, so blue, my axis is in blue here. I know it is negative until I get to C, so let me just mark down my zeros there. So that's 0 and 0 at the very end. It's negative in this region, so I'm just gonna put a little dotted line because this probably will need some adjustment. Yeah, and it's not, I know it will not look like that in the end. But this is just a quick and dirty, at least I've matched this. My velocity, first time. I'm going to put my back to you as I try to line these up. So put A there, B, C. I know velocity is positive 0 at F and I. And it is positive to start out with. And just a really crude sketch. All I've done right now is just match it to this display right here, where it's positive, 0, then negative, and then 0 again. And then acceleration. First time. Well, somehow, so that's what happens when they do it from the side. And acceleration, we start out at, probably easier from here. So it's 0 from A to B, not including B. So I know it's 0 along here, not including B. This is just a placeholder. And then it is 0 from D to E. And then 0 from G to H. And then it is negative, negative, positive. So it's somehow negative, negative, positive, and I know it. All right. Again, all I've done is just match this. I have not gotten them consistent within themselves. Questions to hear before we start fine tuning? All right, I know that this should be the slope of this graph right here. It's the derivative. So that means when my velocity is 0, my slope up here should be 0. So at point F, this should be peaking at F. So that should be a maximum right there. It's 0 at I, and so therefore this should be flattened out here. I should have a slope. So that's going to be, so I sort of start to narrow this down some. My slope is most positive to start with, and so it should be steepest here. It is most negative somewhere around here. Actually, it should be most negative at H. Wait, hold on just a second. Yeah, so H should be the steepest negative that I have, so let's sort of make that a little bit steeper there, and then it starts to level off again. I know that acceleration is the slope of velocity, and I know where acceleration is 0, so this should be flatlined here from A to B. It should be flatlined from D to E. It should be flatlined from G to H. It's negative from B to D, and so it should be sloping downwards there. It's negative from E to G, so again, it should be sloping downwards. And then positive here. Starting to add a little bit better definition to it. Since my velocity is constant along this region right here, that means my slope is constant here. So from A to B, this should be a straight line. From D to E, it should be a straight line. From G to H, it should be a straight line. And so if it starts slowing down, that means my slope starts changing. And so what's going to happen here is I have to make another adjustment here, because if my slope starts getting smaller here, there's no way I'm going to connect up with that spot right there. So I need to make this steeper. Now, as I'm sort of dotting that in right there, I don't want any sharp points, and so the way I have it sort of have it coming in like that, and then straightening out there. So I need to make some adjustment there. And then it is my velocity from C to, I somehow got off track there, let's see. That's negative. Oh, I'm off there. D to E is flat, not C to D.